Going to do a few problems to practice for the review, in review for test 2. So we're given vector u, 1, 2, 3, and vector v, negative 1, 3, negative 2. First, can we find the cosine of theta using the dot product, where theta is the angle formed by u and v. So hopefully we know that cosine theta is u dot v over magnitude u times magnitude v. So u dot v is going to be 1 times negative 1 plus 2 times 3 plus 3 times negative 2 over the square root of 1 squared plus 2 squared plus 3 squared times 1 squared plus 3 squared plus 2 squared. No, that worked out kind of slick. So we're going to get negative 1 on top, and that's going to be the square root of 14 times the square root of 14. And there we have it. That's our cosine of theta. See if we can find sine theta using the cross product. So if you remember, or you need to know, that sine theta is going to be the magnitude of u cross v over the magnitude of u times the magnitude of v. So we need that cross product. So u crossed with v, we're going to do this 3 by 3 determinant, where the first row is going to be ijk, then u is going to be the second row, 1, 2, 3, and v will be the third row, negative 1, 3, negative 2. We're going to use expansion by minors along that first row. So we'll get I times its minor, 2, 3, 3, negative 2, and then minus j times its minor, 1, 3, negative 1, negative 2, plus k times its minor, 1, 2, negative 1, 3. So evaluating this, we're going to get negative 4 minus 9 times I minus negative 2 minus negative is plus 3 times j plus 3 minus a negative 2 times k. So that's going to be negative 13i minus j, and I think a plus 5k. So there is our u cross v. So our sine theta is going to be the magnitude of u cross v. So we're going to get the square root of 13 squared, I think is 169, plus 1, plus 5 squared is 25, over the magnitude of u, and I think we said that was the square root of 14, and the magnitude of v was conveniently also the square root of 14. So let's see, 169, 170, I think square root of 195 over 14, and that'll work for us. There is our sine of theta, and that's what we were asked to find. So can we find the area of the parallelogram formed by vector u and vector v? So this, if you remember, is going to be that the area of our parallelogram is the magnitude of u cross v. And I think we already figured that out in trying to find the sine of theta. So that's going to be the square root of 195. The next one, we have number 4. We have P is 1, 2, 3, Q is negative 1, 3, negative 2, and R is 2, 0, 1. Can we find the volume of the parallelepiped formed by OP, OQ, and OR? So remember, these are our 3 vectors in space, OP, OQ, and OR. They will probably not be right angles, but if we try to, and I'm never going to be able to draw this, if we try to draw kind of the, if you can imagine the kind of box type thing that is formed by those vectors, but it may not be boxes with square corners because it may be pushed over. then our volume is going to be the absolute value of the determinant formed by those vectors. The determinant, a 3 by 3 determinant where we choose the rows or columns to be OP, OQ, and OR. So our determinant, we're going to get, I'm going to choose a different color than red. And so I'm going to go, OP is going to be 1, 2, 3. And then OQ is going to be -1, 3, -2. And OR is going to be 2, 0, 1. So I'm going to evaluate this one by recopying the first two columns and then going down, 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 minus up, minus up, minus up. So there are our copied columns. So if we go down the first diagonal, we're going to get 3 plus, that's going to be -4 times 2 is a -8, plus, and that 0 makes it nice, is 0. Minus, we're going to go up the diagonal. 2 times 3 times 3 is 18. Minus, oh, there's another nice 0, so that'll be 0. And then minus, that looks like -1 times 2 is a -2. So that looks like, let's see, -26 plus 2 is -24. -24 plus 3 is a -21. And our area is going to be the absolute value of -21. So it's going to be 21. Very nice. Okay.